The concepts in Algebra 2, Chapter 2, Section 1 are about functions and relations and some vocabulary that goes along with it. First, what you need to make sure you do is understand these different vocabulary words: a relation, domain, range, and function. So, in your Algebra 2 book, you'd need to first write those down in your notes, and then find the definition in Algebra 2, Chapter 2, Section 1. Go ahead and pause that now. Okay, so what is a function? Imagine the inputs of a function as the button you push on a pop machine. So there's a pop machine, has all these buttons. Those are your inputs. Okay, you push the button, push it in order to get out the pop. So the outputs of a function, imagine those are the pop that you get out of the machine. That pop machine is functioning. It's a function. If for every button pushed, you only get one type of pop out. So if you push the Coke button, you get a Coke out. If you push the Diet Coke button, you get a Diet Coke out. And you press the Sprite button, you get a Sprite out. That's a functioning machine, or it's a function. That machine is not functioning if you press a button and get possibly two different pops. So let's say you press this Coke button, and you could either get a Coke or a Diet Coke. That would not be a functioning machine. That would not be a function. It's the same with functions in math. You have a set of numbers. These are ordered pairs set up as xy coordinates. In this set right here, -2, -1, -2, 3, 0, 3, and 5, 4 is not a function because if the inputs, which are the x coordinates, these are the inputs. I'm going to put a little red dot above each one. If they were lined up like pop machine buttons, notice how there's only 3 because -2 occurs twice. And so we don't need to write it twice. Okay, so -2 occurs twice. And the outputs, which are the y coordinates, I'm going to label those with blue dots. We're lined up like the pops. So you have the pop machine buttons, and then you have the pops. We only have 3 outputs because 3 happens twice. So we only need to write it once when we line them up, because that's the same type of pop. We would see that the input, which is -2, has 2 possible different outputs. So this set of ordered pairs is not a function because of this right here. You have one button getting 2 different pops out. Now, one confusing part is when you're looking at the arrows and you see 2 different inputs getting the same output. And the question comes up, is that a function? This is fine. This would still be a functioning machine if it weren't for this right here, because of this getting 2 out. But imagine a pop machine with 2 different buttons but giving the same pop. You've seen that probably before in a pop machine. They have 2 Coke buttons because everybody wants Coke more. So they have extra Coke. So they have 2 buttons for it, but they get the same pop out. As long as this button gets you this pop and this button gets you this pop, that's okay. You can get the same pop out, but what you can't have is one button that gives you possibly 2 different pops. Okay, so you're up. You need to figure out if both of these are a function or if they're not a function. 2, 6, 3, 6, 4, 5, and 7, 8, and -1, 7, 0, 3, 0, 7, and 1, 10. Your possible answers are yes for the first, yes for the second, no for the first, yes for the second, yes for the first, no for the second, or no for the first and no for the second. Go ahead and try those now. you can set them up like pop machines. Remember, if they're the same number happens twice in the input, like this one, or if the same number happens twice in the output, like this one, then you only need to write it once. Go ahead and try now. For more problems like that, you're going to be looking at page 59, numbers 12 through 15 all. Function notation. A lot of people get confused when they see f parenthesis x because they think it means multiplying. Well, it actually doesn't. It means something different. It's a notation used to keep track of inputs. For example, if I had a function like f of x equals 3x minus 5, in a literal sense, what that means is my function is 3x minus 5. Now, that's not all we're going to use it for, but that's what that means. This is the function 3x minus 5. f of x is 3x minus 5. It's like the pop machine. In the pop machine, if you press a button, what you're doing is you're inputting what you want. In this equation, you're inputting a number instead of a button. But in that pop machine, that pop kind of goes through a little pathway from where it's stored to being dropped through, but not being completely dropped all the way to explode at the bottom. It's being pushed through and then it's being carried down or moved around or whatever. That's a process the machine follows. Just like we follow a process in algebra where we would multiply that number by 3 first and then we subtract 5 to it. We use function notation to keep track of inputs and outputs. Let's say I was to input negative 3 into the function 3x minus 5. Using function notation, I would write this. Here's my input right here. You would plug that in where x was, but you're not going to do anything with this. You're just going to keep track of what you plugged in. F at negative 3 is 3 times negative 3. Again, you input it right here. But on this side, you're simplifying because you're going to simplify the right side. So when you simplify it, you simplify 3 times negative 3, and then negative 9 minus 5, and there is your output. So input, output. Okay? And that's function notation, is just to be able to keep track of these two things very quickly and easily with all this other work in between. So, in short, my function at negative 3 is negative 14, or my input is negative 3, my output is negative 14, and I could write that as an ordered pair where I have an x-coordinate and a y-coordinate. Okay, so I want you to try these ones. Find the function at negative 6, the function at 0, and the function at 5. You're basically pressing 3 different buttons on a pop machine, and you're going to get 3 different pops out. The answers could be either A, 13, negative 5, and 10. So 13, negative 5, 10. Or 13, 5, 10. Or 23, or sorry, negative 23, negative 5, and 10. Or negative 23, positive 5, and 10. And that's it for Algebra 2, Chapter 2, Section 1. Other than needing to do page 59, 22 through 30. Good luck.